This is an overview of reading week 6. The main physics ideas that we discussed are magnetic field of dipole, which can be a current loop or a bar magnet. And then we also discussed the electric potential energy of a uniform field and also mentioned how non-constant E field can also have electric potential energy. For the magnetic field of current carrying loop, we know that the same shape of magnetic field for all planes that go through the symmetric axis exist for any magnetic field of dipole. And a dipole field, the magnitude of a dipole field is kind of similar to the magnitude of electric fields for a dipole. So basically for a magnitude of dipole that's on axis, for the magnetic field, it's going to be the magnetic constant times 2 times the magnetic dipole moment over r cubed. And for the dipole magnetic field that's going to be on perpendicular axis is going to be 1/2 of the magnitude that is in the symmetric axis. What I already knew was that current loop magnetic field for on axis can be calculated using the formula, which is magnetic field constant times 2 mu over r cubed from last week's video. And I also knew the energy principle from physics 2211 last semester. Something that I did not already know was how to calculate electric potential energy and how to plot the electrical potential energy on a graph. Something interesting that I learned is that Earth is also like a magnetic dipole, but the Earth's magnetic dipole is not fully understood and we don't know where its magnetic field arises from. And obviously Earth does not have like a bar magnet that's embedded inside creating this dipole magnetic field. So that was interesting. And how this topic relates to my major, which is electrical engineering, is that electric potential energy matters a lot in circuit building. And I know that we use voltmeter to calculate the voltage, and that's like the difference between electric potential of the wire coming in and going out. Lastly, a confusing topic for this week was the difference between electric potential and electric potential energy. So based on some search on Google, which is from a physicsabout.com website, it states that the basic difference between electric potential and electric potential energy is that electric potential at a point in an electric field is the amount of work done to bring the unit positive charge from infinity, which is from far, far away, into that point. On the other hand, electric potential energy is actually the energy needed to move a charge against the electric field. Thank you.